The bloom threshold in Three.js has a hard cutoff, so let's fix that by making it soft with TSL and React 3 Fiber. Why not use the bloom from the post-processing library? It has softness, which is great, but because of how it's implemented, if you have materials with the same color, you can't make one glow and the other not. So we're going to customize the bloom add-on that Three.js comes with. The first thing I'm going to do is to set up an R3F canvas with the web GPU renderer and pass it a scene component. We want something simple to help us visualize the bloom, so I add a cube and some fog, which gives us some variation in brightness to work with. I'm also going to stub out the bloom and pass it a render pipeline, which we'll define shortly. In case that sounds unfamiliar, it used to be called post-processing before version 183. Anyways, in our hook, we're going to instantiate the class, pass it a renderer, and manage its lifetime with useEffect, setting a ref which we return, and handling resource cleanup as well. Then we add the useFrame hook to call the render method on every frame, as long as our render pipeline is defined. And now we're ready to work on our bloom. I'm going to tackle this in 3 steps. First, we're going to set up the default bloom from 3/addons. Then second, we're going to add softness to the luminance threshold. And third, I'll set up a custom material to apply the bloom selectively. I find small customizations like this to be a great way to learn, and I hope you find it useful too. In order to set up the bloom, we want to import the node, wrap it in a React hook, and connect it to our scene. We create that connection using a pass node which takes our scene and camera. It gives us a texture containing the whole scene, which we can pass to the bloom node. Then, we take our bloomed output and add it back to our original output to get our combined scene. But we want to use sliders to control our bloom parameters, so there's some additional work to do. Let's wrap our bloom setup in a function that returns uniforms along with the node we created. Now, we can set those uniforms using values from a state store and update them whenever the sliders change. Here's how I define the values and setters for the bloom radius, strength, and threshold. But we still need to connect it to our actual node, so let's do that. The getBloomNode function takes our scene output texture from earlier, sets default values for our uniforms, and calls another function where we add our bloom to our output and connect the uniforms. Add state store values for changing the color and toggling the wireframe, and we have version 1 of our bloom. The benefit to doing things this way is that our bloom node is self-contained, meaning we can make changes to how it works without affecting other parts of our code. But before we do that, let's go over what changes we need to make in order to add softness to the luminance threshold. The basic idea behind how bloom works is that we take our scene output, filter it based on luminance or brightness, then apply a blur and glow to the remaining parts. So to create our soft bloom effect, what we need to do is to add a buffer around that luminance threshold where we transition from affected to unaffected. How do we determine luminance? We can calculate it by taking the dot product of our texture's RGB output and a vector with weights representing how sensitive our eyes are to red, green, and blue light. Then we pass in a new uniform called knee, which represents the size of the buffer we want above and below our luminance threshold. Between those upper and lower bounds, we want to create a gradient of values, and the easiest way to do that is to use smooth step. So we pass in our 3 parameters, the knee start, knee end, and luminance, to generate a mask which is a softer version of our luminance texture. If we multiply our original texture by this new soft mask and pass it to the Three.js bloom node, that's how we can get our soft bloom. And because we're applying the threshold outside of the add-on, we no longer need to connect the bloom node's threshold value to our threshold uniform. But we do need to make sure to add our knee value wherever we're using our uniforms or state store values to make sure that everything stays fully interactive. Let's add a second cube to the scene and work on applying the bloom selectively to one but not the other. The classic approach, which is also mentioned in the post-processing library, is to use the emissive intensity to push color values outside of the 0 to 255 range into the HDR space, and to set the luminance threshold such that colors in the normal range will not receive bloom and anything above will. But the problem with this method is that you can't have 2 objects sharing the same color and only selectively apply bloom to one of them. It also prevents you from using tone mapping for the colors in your scene, because it clamps your colors to the standard dynamic range from 0 to 255. The first solution I explored was to add a second camera to the scene, which only sees some objects, the ones we want to be affected by bloom. You'll see why that solution wasn't sufficient, but I'm sharing it because the core idea behind it applies to the solution that I did end up going with. We start by placing one object on a separate layer. We're going to treat layer 1 as the bloom layer. Then we create a second camera by cloning the default one. Our goal is to make it so that it only sees the bloom layer. We use the pass node again to take the output of this second camera and pass it to the bloom node. We take the output of this operation and add it to our original scene texture to get the result that we're looking for. But we still need to configure the camera. We can do that with the use frame hook, where we can set the camera position on every frame and also tell the camera to look at layer 1. You need to do this even though we define the bloom camera by cloning the default one, because that's not enough to tell the camera to update its position. Now, at first glance, the bloom looks fine, but if you look closely, you'll notice that there's an issue with the depth. We could solve this by creating more textures and writing depth information to them, but thankfully, we don't have to do that, and there's an easier way. Instead of using a second camera and pass node to render a copy of our scene, we can handle everything in the original scene pass using something called MRT, or multiple render targets. So we can safely delete our bloom pass and call the setMRT method on the scene pass instead. This takes an MRT node and output that we import from Three.js and also takes a string key for any render targets that we want to define, in our case, bloom. And I set the value to 0 or 1 depending on whether or not I want to enable bloom. For the overall scene, we want to disable bloom, so I pass 0 as a const node. Now we can access a separate texture for our bloom layer by calling scenePath.getTextureNode, the same way we do for our overall scene output. Now we're going to take both of these texture layers and pass them to our bloom node. And where we call the bloom add-on, we want to multiply our scene texture by the bloom mask, so that only objects written to the bloom layer are affected. So how do we write to our bloom mask? Because we're not able to use layers as we were before. The answer is to create a material and to set its MRT node where we can tell it to write to an additional render target. So our object will write to both the scene output and the bloom layer. For convenience, we can return this material from our use bloom hook. In React 3 Fiber, the way to use this custom material in our mesh is to use a primitive in the render tree. Our custom bloom is working nicely now. We have our soft transition on the luminance threshold, selectivity even if materials share the exact same color, and no depth issues. I used this effect in a stylized flame shader. Check it out if you're interested.